Let's begin. Step number 1, gather data. Two very important points to remember here. You need about 20 to 25 consecutive data points to construct a meaningful control chart. Less than 20 or more than 25 points might skew the results. And the second one is, these points must be continuous in time or must have constant time interval. You cannot record the first point today, second one next week, and the third one in the fourth week. That's not a constant time interval in between two data points. Let's see, how does our data for patient no-show look like? This is the data for a group of 30 physicians recorded over 25 consecutive days. See, this is continuous data recorded from the same source. And this is very important. Data source must not change as it might compromise data integrity. Great, now we have the data. Let's move quickly to step number 2. Here we calculate mean or average value for this data. Now here we have a set of 25 data points. For this we simply add 25 data points and divide them by 25. That is sum of all the values of 25 data points in our data set and divide the total by 25. Here we get the average of 15.76. 15.76 patient no-shows average. Here we are using Excel tables. We use Excel to build these tables, but one can do all these calculations by using a simple calculator. And I would recommend, if you are learning this topic for the first time, practice building control charts using calculator, paper and chart papers. That will hammer the process into your brain, and once that happens, you can use any software you want to create your control charts. Alright, let's move to step number 3. Here we calculate the moving range for the data, or moving ranges for the data. If you see online or in any books, reference materials, you will see many types of control charts. They have specific uses, but for the control chart we are discussing here and we are going to use and Carrie used in her case of patient no-shows, we need moving ranges. As we go on building the chart, you will see how do we use these moving ranges to anticipate or predict outcomes. Now, moving range calculation is very simple. You subtract the value of previous data point from the value of next data point. For example, data point number 1 here will not have any moving range because that's the first observation. There is no observation before that. So first data point recorded will not have any moving range. We go to data point number 2. We subtract the value of data point number 1 from the value of data point number 2. And one very important thing, here we take the absolute value of that answer. Now absolute value is something that returns positive value. Always it returns a positive value. That means even if you get your answer as a negative answer for moving range, the absolute value of that answer is going to be positive value, and we take that positive value for the moving range. Now here the moving range for data point number 2 is going to be 25 minus 15, that is 10. Now this is a positive value, but moving range for data point number 3 is going to be 13, even though the subtraction of 2 from 3 yields negative 13. Remember, we have to subtract value of previous data point from the value of next data point. So the subtraction answer is negative 13 for points number 3 and 2. but the absolute value of that answer is positive 13, and we take that positive absolute value for the moving range. Now we similarly calculate moving ranges for all these values. Here we will have 24 moving ranges because there are 25 points, and we do not calculate moving range for the first one because there is no observation previous to that observation. So here we have moving ranges for all the values in our data set. Let's go to next step, step number 4. Now, like we calculated average for our data, average for 25 points, we are going to calculate moving range average for all the values of moving ranges we just calculated. So let's add up all the values of moving ranges here and divide them up by the count of moving ranges. In this case, all moving ranges add up to 146, and then we divide them by 24 to get our average as 6.08. This is our moving range average. We are going to need all these answers of all our calculations so far when we calculate different things for our control chart. Now you see here our patient no-show average is 15.76 and our moving range average is 6.08. What does that tell us? It tells us that our average of patient no-shows is expected to move in either direction, up or down, by an average of 6.08. Now, can you split patients? No. So the more appropriate interpretation would be the average number of no-shows of 16 patients per day. We might get 16 plus 6, 22, or 16 minus 6, 10. Pretty straightforward, right? We rounded off numbers 15.76 to 16 and 6.08 to 6. So 16.6, 22, or 16 minus 6, 10. Okay, now the fun begins. Now we are going to plot the chart. Next step, step number 5, is to plot the chart. Now this chart is without any limits. We don't have limits yet, the control limits that we require for control charts. We plot these values of all the patient no-shows in our data set, and we also plot this horizontal line that shows us average number of patient no-shows or average for that data set. Now in technical terms, this is called a simple run chart with average line. What we get next when we calculate upper and lower limits and we put those on this chart is a control chart. So let's go to step number 6. Calculate upper control limit and lower control limit for this data. Now this is going to involve little calculations, but like we do in every video, in every content that we create, we are going to simplify and demystify those formulas for you. Now these formulas are going to give us control limits, what we call 3 standard deviations above the average and 3 standard deviations below the average. So let's look at the formula. Here we have average. We know we calculated average in step number 2, average for the data set. Next one is moving range average. We calculated moving ranges in step number 3, and then we calculated moving range average in step number 4. Now you are going to ask me, what's the deal with this 1.128? What does that mean? Well, if you wanted to get into the statistical formulas and all, it would get complicated. You'll have to understand the statistical theory and all the calculations behind it. It would look like something like this. But we are going to simplify that and take this value 1.128 to do our job. to calculate upper control limit and lower control limit for our control chart. 3 standard deviations above, that's the upper control limit, and 3 standard deviations below, that's the lower control limit. Now, slightly technical here, if you want 1 standard deviation above or 2 standard deviations above and below, you will have to use different number instead of 1.128. But most typically, people use 1.128, or people use 3 standard deviations above and 3 standard deviations below the average. So we are using 1.128, 3 standard deviations above, 3 standard deviations below. Let's quickly put our values in these formulas, and we get upper control limit as 31.93 and lower control limit as negative 0.41, negative 0.41. Wow, something very interesting happening here, right? We are getting a negative control limit. What does that mean? Well, that's the beauty of mathematics. It will give you the value, the answer. The formulas will give you sheer mathematical answer, but then you will have to have knowledge of the processes you are monitoring or you are working with, and the common sense to interpret these limits. In this case of patient no-shows, we are studying the process around patient no-shows. The value can never be negative. It can go to 0. The number of patient no-shows can go to 0, but they will never go negative. That's why here for this case, we discard this negative control limit and accept 0 as more natural lower control limit for this process. So our control limits become the upper control limit 31.93 and lower control limit 0. Now the next step, of course, step number 7 is to put these control limits on our chart, the chart that we plotted previously before we calculated the limits. And this is how it looks like. Our control chart is ready. Now the only thing remaining, last but not the least, is to interpret this control chart to see what this control chart is telling us. But before we go there, let's recap the process we have done so far to plot these control charts. We are using average and moving range control chart. We selected the process to monitor. In our case, that is patient no-show process at the clinic. Then we identified the metric we want to use, that is number of patients, number of patient no-shows per day. Then we collected 25 data points, observations, 25 consecutive data points. We calculated average of those 25 and also calculated moving ranges. Then we calculated moving range average. And then we used our ready-made formulas to calculate 3 standard deviation above and 3 standard deviations below our average, that is our upper control limit and lower control limit. And then we of course plotted those limits on our run chart to prepare to make our final control chart. Now let's go to interpretations. This is critical. So critical that if we don't know how to do this, control charts are of no use. It's like saying that I can design an experiment, run the experiment, but I don't know how to interpret the results. So let's see what do we need to know to interpret results of our control chart or process behavior chart.